This planet is definitely the closest planet to the sun that's not orbiting the sun. So the star is called Proxima. We used to always call it Proxima Centauri, which is just Latin for the closest thing in the constellation of the sun.
The phrase "we do not rest here" should have been coined by NASA, because not only has this organization revealed the unthinkable about the universe, but their Webb telescope has also found another fact that might not be fun from the universe. And we're not talking about galaxies here. Nope. Now we move to find mysteries from planets we don't know even exist. Have you heard of Proxima b? Many of you haven't. Of course, it is not Neptune, but like other known planets, what could be different about the TRAPPIST that was discovered by the James Webb telescope? Let's find out. Rumours have circulated for some time that the James Webb Space Telescope has discovered a planet with strong signs of life. Some of this opinion recently gained public attention when the British news magazine, The Spectator, published an article titled, "Have we just discovered aliens?" This question we have no answer to. For one, NASA seems to have a lot of things under their blankets, but we aren't complaining, for now. But that's not our point of discussion. Our focus lies on the exoplanet Proxima b. But first, what is an exoplanet? It is any planet outside of our solar system is known as an exoplanet. The majority of exoplanets orbit other stars. However, some are free-floating and referred to as rogue planets because they orbit the galactic center without being connected to any star. Our present universe is made up of exoplanets. There are thousands of confirmed planets, and the number is still growing. That represents only a tiny fraction of the entire cosmos. If we expand the quantity and viewing power of robotic telescopes sent into orbit, the count might reach the tens of thousands in less than 10 years. In 2021, astronomers anticipated that the James Webb Space Telescope would be able to detect artificial light on the nearby exoplanet Proxima b. The study, conducted by a team comprising of renowned Harvard astronomer Avi Loeb, argued that the optical telescope could be constructed to spot indications of LED light on the planet Proxima b, orbiting Proxima Centauri 4.2 light-years from the Earth. Knowing about the planet. According to research, Proxima b is the closest exoplanet neighbour that resides in the habitable zone of Proxima Centauri. Now, it is okay if you get a bit confused, but let's help you out a notch. What is the Proxima Centauri? Discovered by Robert Innes in 1915, the Proxima Centauri is a small, low-mass star located 4.2465 light-years, 1.3020 parsecs away from the Sun in the southern constellation of Centaurus. It is the nearest known star to the Sun, with a quiescent apparent magnitude of 11.13, and you guessed it right, it is too faint to be seen by the unaided eyes. Needless to say, the deviation was necessary. Let's get back to talking about Proxima b. Proxima b is a tantalizing world that scientists have been eager to study due to its potential signs of having life, making it one of the many major discoveries in planetology, and has drawn interest to the Alpha Centauri star system as a whole. Light plays a crucial role in determining if there is life on a planet. But the question then is, can we truly detect light from Proxima b? Keep in mind that this planet resides on another planet. Now that is where the James Webb Space Telescope comes into play. In some of our videos, we have spoken deeply about the James Webb Telescope. However, we haven't touched on the quality features of this amazing tool that has influenced historical knowledge and what it is made of. For the course of this video, and to understand why many believe this telescope would find greater mysteries and discoveries, it is imperative you know: can Proxima b support life? The question remains intriguingly open. Is there any chance that Proxima b could support life? Harvard University physicist Avi Loeb and astronomer Laura Kabur propose using the JWST to obtain the answers. The JWST makes it possible for scientists to examine patterns that suggest the existence of water or an atmosphere by capturing infrared light reflected off the surface of Proxima b. As astrophysicist Ed Turner points out, it's crucial to remember that the existence of an atmosphere does not always imply the existence of life. With its thick atmosphere and hot temperatures, Proxima b may resemble Venus. However, the latest strategy developed by Loeb and Chabur continues to be our greatest option for even getting a look at this potentially livable planet. Features of the Webb telescope. The telescope boasts a primary mirror made of 18 hexagonal mirrors, coated with gold and measuring 6.5 meters, 21 feet in diameter. This mirror, with a polished area of 26.3 square meters, 283 square feet, features 0.9 square meters, 9.7 square feet, obscured by secondary support struts. The total collecting area sums up to 25.4 square meters, 273 square feet, a considerable increase compared to the Hubble telescope's 2.4 meter, 7.9 feet diameter mirror, which has a collecting area of 4 square meters, 43 square feet. Also, the mirror has a gold coating to enhance infrared reflectivity, and for added durability, it is encased in a thin layer of glass. In essence, the giant mirror and advanced instruments help it to peer into the universe with unprecedented clarity, but can we trust it enough to catch a ray of the Proxima's light? The answers and beliefs. We've seen curious individuals interested in the future of the universe question NASA officials about whether they had genuinely discovered life with the Webb telescope, or, at the very least, significant evidence of life on another planet around a star other than our own. We didn't get a positive answer. JWST has not found definitive evidence of life on an exoplanet, stated Nicole Colon, the telescope's deputy project scientist for exoplanet science. It is anticipated that JWST observations will lead to the initial identification of potential biosignatures that could make habitability more or less likely for a given exoplanet. But whether a certain exoplanet is habitable or not, future missions will be needed to conclusively establish the habitability of an exoplanet. Although she didn't state it, Colon is referring to K2-18b, an exoplanet 8.6 times the mass of Earth, located 120 light-years away. Astronomers believe this could be a Hycean exoplanet, which means it has water seas on its surface and a hydrogen-rich atmosphere. To confirm Proxima b's existence, scientists launched the Pale Red Dot study in 2016. Under the direction of Anglada Escude, the team announced the finding of Proxima b and provided proof that it is habitable inside Proxima Centauri's habitable zone. The presence of water and atmosphere. The main emphasis of the probe of Proxima b is the examination of its atmospheric composition and water content. Proxima b may have water, which gives rise to expectations for possible habitability. Furthermore, an atmosphere might disrupt heat to the planet's dark side and protect it from extreme surface heat. In figuring out these aspects, the JWST's capacity to interpret infrared photos becomes essential. Nevertheless, considering the complexity of planetary atmospheres and the limitations of existing technology, finding conclusive solutions continues to be difficult. Astronomers had recently investigated this planet using the Hubble Space Telescope, but their attention was piqued when the Webb telescope, which began operations in 2023 after launching in late 2022, made some unexpected findings. Webb discovered dimethyl sulfide, among other chemicals. It is important to note that dimethyl sulfide is only produced by life on Earth, which does not prove the existence of life on K2-18b. However, if dimethyl sulfide exists there, it is unquestionably a startling clue. Dimethyl sulfide is an organic compound that you may have smelled if you have ever cooked cabbage. While many might be expectant about this planet, we haven't gotten precise answers to our questions. This might be due to the challenges that come with studying this planet. For one, we have the challenge of the presence of life versus the presence of atmosphere. Even while having an atmosphere is crucial for determining if a planet is habitable, life is not always present in these worlds. Astrophysicist Ed Turner notes that life as we know it is not possible in a dense atmosphere, similar to that of Venus. As a result, Proxima b's atmosphere alone does not provide sufficient evidence for its habitability. It would take a variety of techniques and observations for scientists to fully comprehend this foreign environment. But even as we haven't gotten any clear answer on Proxima b, we know that the discovery of and its clear image is not in vain. An important step has been taken in our quest to find planets outside of our solar system that might harbour life, the finding of Proxima b. The JWST's capability to take pictures of planets other than our own creates a plethora of opportunities for further exploration. Even though Proxima b is young to Earth, it provides a reminder of the size of the cosmos and the possibility of life elsewhere in space. Also, Proxima b is thought to be between 15 and 20 million years old, a young planet in comparison to our 4.5 billion year old Earth. This young age prompts fascinating inquiries concerning the planet's creation and evolution. Proxima b's designation as a gas giant is clarified by observations made by Sasha Hinley, an associate professor of physics and astronomy at the University of Exeter. The planet is unlikely to support life as we know it because of its lack of a rocky surface, but more investigation and study can provide a clearer picture of its special qualities and reveal more about its habitability potential. So, as far as we can tell, that is what we know. Scientists are interested in Webb's observations of the exoplanet K2-18b. However, there is a heated controversy over the telescope's observations of water, methane, and dimethyl sulfide. They are promising, but not definitive. As Colon stated, we need additional data and potentially new equipment to make a clear decision. So the entire narrative has yet to be told. Your insights are invaluable to us. Do not forget to hit the subscribe button. Also, feel free to share your thoughts in the comments section.